About quadratic functions again, but we're going to talk about them as far as graphing quadratics. Again, just a quick little overview. A quadratic function is a function in the form ax squared plus bx plus c. We've seen that before. A, b, and c are real numbers, and a cannot be 0 because then it wouldn't be an x squared term. First of all, an important property that has to do with graphing. You'll see these graphs down here. A quadratic graph is called a parabola. So sometimes you just refer to it as quadratic graph, but if you hear parabola, then that's talking about a quadratic as well. If a, which is the constant that goes with x squared, is positive, then the quadratic opens up. Okay, you can see that here. If a is negative, the number with the x squared is negative, that means your quadratic is going to open down. So the graph is going to open down. That's important to remember. That can help you a lot when say you're matching a quadratic function to the graph. If you know that property, that sometimes can help you eliminate answer choices. All right, some other pieces of a quadratic graph. You have x and y intercepts. X-intercepts, of course, are where a graph crosses or touches the x-axis. Y-intercepts are where a graph crosses or touches the y-axis. And then we have a line of symmetry. I would get used to calling this the axis of symmetry. That's usually how it's referred to. That is a line that goes right through the middle of the parabola. The parabola is symmetric to that line. So you have 2 points on each side of that line, equal distance away, that are on the parabola. And then down at the bottom, notice you have what's called the vertex. The vertex is the only point on the parabola that is on the axis of symmetry. Okay, your vertex is either going to be your highest point. Now, before we said our graph could either open up or down. So if your graph is opening up, then your vertex is going to be your minimum or lowest point. If your graph is opening down, then your vertex is going to be your maximum or highest point. Okay, notice here, this is one where the parabola is opening up, and so that vertex is the minimum, the lowest point. Okay, here's another informational slide. Before I take a look at what's at the top here, what I want to talk about are these pictures here, because this has to do with your different types of intercepts. Now, y-intercept, you are only going to have one y-intercept, okay? Every time you're only going to have one y-intercept. There's only going to be one point where the graph crosses the y-axis. However, you have different possibilities for the x-intercepts, and that's what I have graphed here, 3 different possibilities. The first one is that you could have 2 x-intercepts. Notice here, this graph crosses the x-axis at 2 different places. Okay, it's opening up and the vertex is below the x-axis, so it's got 2 different x-intercepts. The next one only has 1 x-intercept. Okay, and it's actually not crossing the x-axis, it's just touching it right here. And this is one where the vertex is actually on the x-axis, which means the y-coordinate of the vertex is equal to 0. And then finally, over here on the far right, you'll notice that we have no x-intercepts. This graph opens up and the vertex is above the x-axis, so there's no way for this graph to ever cross or touch the x-axis. Okay, and you can have all of these in reverse if you're opening down. Okay, you can still have the same cases if you're opening down instead of opening up. So we have 3 possibilities for x-intercepts. We could have 2, 1, or none. We will always have 1 y-intercept. Okay, now up here, this is something that is very important for finding your vertex. You always want to start by finding the x-coordinate. And I do have an easy way. I'm going to write it out kind of more in words. To find your x-coordinate of your vertex, notice here, negative b over 2a. That's what's important there. That's how you find the x-coordinate of the vertex. To find your y-coordinate of the vertex, you just need to plug back in whatever you got. Okay, so f of negative b over 2a. That's why that's over there as the y-coordinate. It's a lot easier. There's a big complicated formula for that for every quadratic, but I think it's easier to just remember, hey, whatever I got for the x coordinate, I plug back in to find the y coordinate rather than trying to find another or memorize another formula. To find your x and y intercepts, those are very easy. To find your x-intercept, you want to set the y equal to 0 and solve, which we've already learned how to do. We've learned how to solve quadratic equations. At that point, we are either factoring or using quadratic formula. To find the y-intercept, you want to set x equal to 0 and solve for y. Really quick, I want to take you back, take a look at something. Take a look at our form for quadratic. If we plug in 0 for x, notice that these terms are going to cancel out no matter what they are because we're plugging in 0 for x, so those are going to be gone. And what's going to be left is your c. So an easy thing to remember for y-intercept, okay, your y-intercept is always the c value. Okay, so whatever the c is in your quadratic equation, that's your y-intercept. And that makes it really easy to find it. You don't even have to remember to plug anything in. You just remember, hey, my c value is my y-intercept. That's where my graph touches or crosses the y-axis. Okay, let's go through an example finding all of these things. Okay, so we want to find vertex, axis of symmetry, y-intercept, point symmetric to the y-intercept, and graph the parabola. We also want to find, I didn't list, but we want to find the x-intercepts. Okay, so let's do that as well. Let's do it all. Okay, so let's start. We can find our vertex by using that formula we just learned. We can find the x-coordinate of the vertex by using negative b over 2a. So let's take a look at that quadratic formula. B is negative 8, so negative 8 becomes positive 8 over 2 times a. A would be 1. So 8 over 2 gives us 4. So we've got the x-coordinate of our vertex. To get the y-coordinate, we just want to plug back in what we got. 4 squared minus 8 times 4 plus 12. Okay, 4 squared is 16 minus 8 times 4, so minus 32. And then plus 12, we're going to end up with negative 4. So 4, negative 4 is our vertex. We could go ahead and plot that point if we want to. Okay, here's our vertex. Next, axis of symmetry. I want to go back and show you something. So when we looked at this graph of a parabola and the properties, notice that the axis of symmetry is a vertical line that goes through the vertex, right? Okay. A vertical line has the form x equals some number. Okay, that's a vertical line because notice the x coordinates are all the same, right? The x coordinates here in this particular case are all 1. Okay, so your axis of symmetry is always x equals a number. So let's go back and see what we found out about our parabola here. So we know that that axis of symmetry is going to go through this vertex, and it's going to be x equals a number. Well, we said our x coordinate for our vertex is 4. So our axis of symmetry, which I'm going to abbreviate AOS, is x equals 4. Okay, that's going to be a vertical line. So I'm just going to make it a little dotted line going through 4. Okay, so there's our axis of symmetry. Next, we need to get the y-intercept. Remember, we said that's easy to find. Y-intercept would be 12 because it's the c value. And we don't have that on here because that's way too high, so we won't plot that. Next, we want to have, I didn't list it, but I want to find them. Let's practice finding these. Let's find the x-intercepts. So remember, for x-intercepts, we want to set the y equal to 0. That's your f of x. So we have x squared, minus 8x plus 12. Now, 2 ways we can do this. You can factor this one and solve, or you can use quadratic formula. I'm going to factor because that's pretty quick and easy. In this case, we need 2 numbers multiply to positive 12 and add to negative 8. So x minus 6, x minus 2. And then if we solve, that's going to give us x equals 6 when we add that over, and x equals 2 when we add that over. So notice we now have our x-intercepts at x equals 6 and x equals 2. So if we try to graph this, and please forgive me, my terrible graphing, I'm trying to do it on the screen. It's a little shaky, but you know, could be worse. There we go. So that's a rough, very rough graph of our parabola. We know it opens up because, well, it fits the shape, but also notice that we had a positive x squared, so our graph should be opening up, and then all of our data fit that. We have a vertex, and then we have our two x-intercepts. Okay, let's try one more. Okay, graphing, and we're going to do the same thing. We're going to find all that information. Let's find the vertex first. Okay, so find our vertex. We know x is negative b over 2a. Let's take a look at what we have. B, in this case, the term with the x is negative 8, so negative 8 becomes positive 8 over 2 times a, which is 2, the number with the x squared. So 8 over 4 becomes 2. So now we have the x-coordinate of our vertex. We just need the y. To get the y-coordinate, let's plug this back in. So we have 2 times 2 squared minus, 8 times 2 plus 5. Okay, let's see what we get. 2 times 2 squared is going to be 2 times 4, which is 8, minus 8 times 2, so minus 16, plus 5 is going to give us negative 3. So our y-coordinate is negative 3. So we can plot that to negative 3. Okay, that's our vertex. Now remember what we said, our axis of symmetry is an x equals line. It's a vertical line. It goes through the x-coordinate of the vertex, so that line is x equals 2. Okay, next let's find our y-intercept. Okay, remember that's the c value, which is 5. So we have a y-intercept at 5. And oh, look, this time we can plot that. It'll fit on here. Next, we need x-intercepts. Okay, so let's say we have this equal to 0, 2x squared minus 8x plus 5. Okay, now let's see. Would this one be factorable? We would need two numbers that add to negative 8 and multiply to positive 10. I don't think that's going to work out. So this one isn't factorable. So we would have to use quadratic equation, the quadratic formula. So let's set that up to find our intercepts. Okay, negative b, which will be positive 8, plus or minus square root of b squared, so negative 8 squared, minus 4 times a, which is 2, times c, which is 5, all over 2a, so 2 times 2. All right, let's tidy this up just a little bit. So we would have 8 plus or minus the square root of negative 8 squared is going to be 64 minus 4 times 2 times 5. It's going to leave 24. 4 times 2 times 5, of course, is 40. So 64 minus 40 gives us 24 inside that square root. 2 times 2 on the bottom is 4. So let's find these decimals. 8 plus the square root of 24 divided by 4 gives us, let's see, I'll write it over here, 3.225. And then 8 minus the square root of 24 divided by 4 gives us 0.775. Okay, so obviously this is not going to be perfect. You're going to have to estimate a little bit when we graph. So 3.225 is going to be closer to the 3. And then 0.775 is going to be close to the 1. Okay, now again, forgive me for this rough drawing that I'm going to do. We know this opens up and it's, whew, let's try that again. Okay, a little bit better there. Okay, not perfect, but decent. This is opening up. Again, notice we have a positive 2x squared, so we know it has to open up. Okay, now we found these take a while. That took us a while to go through all that information, okay, and find all those different pieces. So this is not something I would expect you to be able to do quickly. However, we may see some problems where you are trying to find, just match up something. And that's what I have for us next. We want to match the equation of the parabolas, which are numbered 1 through 6, with the graph A through F. Okay, now notice we have 4 that are opening up. We have 2 that are opening down. So let's take a look at the 2 that are opening down. Those have to match up with 4 and 5 because those are the only 2 that have a negative with the x squared. See how quick we can figure that out just based on knowing the properties of whether it opens up or down. Now, let's take a look really quick. Something that I'm going to notice right here, the y-intercept for the graph with f is at 0. Okay, that means the c value would have to be 0 for that equation, which means there shouldn't be a number added out to the side. Notice for number 4, we just have negative x squared plus 4x. Okay, also if we set that equal to 0 to get the x-intercepts, notice we would get 0 and 4, which are the x-intercepts here. Okay, we could also find the vertex. Negative b over 2a, negative 4 over 2 times negative 1 gives us positive 2 for the x-coordinate. Plug back in, and we would get 4 for the y-coordinate. So 4 matches up with f. Okay, so we've already done that one, which now means 5 has to match up with D, process of elimination. Notice that the C value is negative 16, the y-intercept is a negative 16, and notice this one's tracking downward where that seems like it would fit. We could find our, excuse me, x-intercept if we needed to, which also ends up being the vertex. So this one matches up with D. All right, let's take a look at some others. Notice that, let's see, we could take a look definitely at some y-intercepts. That might help us out. Take a look at B. We're opening up. Our y-intercept is at the same place as our vertex, which is down here at negative 2 for the y. That means the C value has to be negative 2. That matches up with 3. So 3 has to go with B. Notice that the x-coordinate of the vertex would be 0 because we don't have anything as a B term. Okay, anything with the x. Okay, let's keep going. The rest of these open up. Again, looking at our y-intercept can help us a lot. Take a look at A. Y-intercept is at negative 1. That means the C value has to be negative 1. Notice that the only one that has that is 6. 6 has to go with A. And everything else will match up if we check it. Okay, we could find the vertex, negative b over 2a. That's going to give us negative 1 for our x-coordinate. Plug it back in and get negative 2 for the y-coordinate of the vertex. Let's take a look at C. C, we can't see the y-intercept. It looks like it's going to be bigger. So let's skip on down to E. E, notice, has a y-intercept at 4. Okay, so the C value has to be 4. That matches up with number 1. So number 1 has to be E. Okay. Also, if we solve for the vertex, negative b over 2a is going to give us 2 for the x-coordinate. Plug it back in, we'd get 0 for the y-coordinate, which is also the x-intercept. Last one left is C, which means it has to match up with 2. Let's talk about a few things. The C value is 16, so that means that the y-intercept is way up high at 16, which matches with this graph. We could find the vertex, negative b over 2a. So negative 8 over 2 times 1 is going to give us negative 4 for the x-coordinate. Plug that back in and we would get 0 for the y-coordinate, which is also the x-intercept. Okay. Again, knowing those small things about how things relate to each other with these graphs can help you a lot. We did this matching activity very quickly, even though we had 6 graphs to match up, using the things that we know about whether they open up or down, using little tricks like knowing the C value is your y-intercept can help a lot as well. And then if you need to further differentiate, maybe you have multiple ones that have the same y-intercept, you can always look at your vertex as well as your x-intercepts. All right, guys, hopefully this was helpful. You're going to have some more practice on graphing quadratics and properties of graphs after this.